When we're looking for the domain of a function, it really depends on what type of function that we're dealing with. If we have just the plain old polynomials, there are no restrictions. So I want you to think about mathematically why we would have a problem with particular x values. Well, there's really only two rules at this point that we need to worry about. We can't take the square root of a negative. If you try to take the square root of a negative, it's not going to work. And we can't divide by 0. So our domain rules are really only addressing those two things. So for a polynomial where you had, something like 2x squared minus 5x plus 1, your domain here is negative infinity to infinity. It's all real numbers. If you have, just something like 5, well, it's just 5 for every value of x. And if you have a function where it's, a line, 3x minus 1, again, that one's all real numbers. So polynomials are always okay because we can always take any value of x, plug it in, get a value. We're not breaking one of the rules with square roots or by dividing by 0 because there are no square roots or division in these problems. So our problems become when we need to do a radical function. So let's say that we wanted to take the square root of 2x minus 1. Well, I better make sure that what's under my square root is positive or 0. 0 is okay. So I set 2x minus 1 greater than or equal to 0, and then I solve this inequality. And here we get that x is greater than or equal to 1/2. And in interval notation, we would do close brackets 1/2 to infinity. And so your inequality rules come into play here with those. Now let's take a look at the cube root. Cube root's not a problem because I can take the cube root of whatever. Okay, I can take the cube root of x cubed minus 1. The only time your cube root is a problem is in the rare case where you're doing the cube root and you have a fraction under there, because then you get your division by 0, and so you have to look at what the denominator would be to cause that to be 0. And so just set that denominator equal to 0, solve it, and that is the value you would have to exclude. But other than that, we don't have any problems. And then finally, our rational functions, these are the ones where you have a fraction. So if we have f of x, and I'm just going to do a simple one here. We will do a little bit of factoring though. Where we have x squared minus 4, and I need to solve that. What I recommend doing is if it can be factored, or if it needs to be factored, go ahead and factor. Because what we're looking for is what is going to make the denominator 0. So we set both of those factors equal to 0, and we solve. So here, x equals -2, x equals 2. Both of these would be problems. Both of these would make the denominator 0. So when we do our interval, we have to skip -2 and 2, and I'm going to have to move over to the left so I have room. To do this, I'm going to skip over -2 and skip over 2. And I skip over that with that open parentheses and the u, and then jump back over. And then for the questions like 6, 7, and 8, this is just function notation. So this is actually going back to section 1.4. And here, I'm just looking for f of -1. So what that means is I know that x equals -1 from that function notation, and I'm trying to figure out what that y value is, because your function notation is representing the y value at a particular x value. So for -1 here, go to the graph. Where is that function? What is the ordered pair there? Notice here it's -1, -4. And so the answer to this, f of -1, we're looking for -4. We can do other points here. F of 0, I'm looking for the point there. F of 0 would be -3. Again, looking at the graph, you're given the x value in parentheses, and you're just looking for the y value. F of 1 would be -4, and f of 2 would be up here at 5. So for 6, 7, and 8, all you have to do is find those function values by looking at the graph. And then finding the domain and range, or sorry, just the domain. No, you need both, sorry, domain and range. For the domain, you're looking for the x values where this function is defined. Notice it's an open circle here, so that's going to be an open parentheses, and a closed circle on the right. And so that domain is -2 to 2. Then for the range, what's the lowest y value that you have? And here we actually equal -4. And what's the highest value? Here we equal +5. And so our range is going to be -4 to +5. So 6, 7, and 8 all work like that.